Okay. Hi everyone, thanks for coming and welcome to Hidden Types with Scala macros. I'm Marina and I'm a software engineer working on Scala for a couple of years. Before that, I was a student and didn't know about Scala at all, so I basically started my career with Scala. By the end of this talk, you will have an understanding of how to use Scala macros to work with schemaless key-value data storage. You will know how I came up with that idea and how I can help you to reduce runtime errors in your application. Now to the topic of the talk. We can use schemaless key-value storages to build distributed cache or for the tasks when we need fast response from the database. It's also often used in big data. But sometimes there is no Scala library available for us, and when all you need to do is that a couple of operations with a particular database, you will not spend your time writing a full driver. You will just take what's out there. And usually we end up with the most popular version written in Java. But we can work with a trusting compilator with everything, like we used to in Scala. And today we will try to solve that problem and return to the bosom of this strongly typed language by writing a small library on Scala macros. As a test, I took a spike, but this approach can be used for other schemaless key-value storages. I undertook some research, looked through different libraries, tried different implementations, and today I'm going to show you my solution. So, roadmap for today. First, I would like to tell you about Spike and how we store data in it. After, I will explain what I think schemaless key-value data storage driver has to do and why is it so important to operate with types in Scala. And finally, I will show you my solution for these issues implemented with Scala macros. My talk will take about 30 minutes, and I will leave time at the end for the questions. So, Spike is a schemaless storage. It means when you need to change the type of the data, you don't have to modify schema. Namespace, set, and bin are three essential concepts here related to data storage. Within a record, data can be stored in one or many bands. They all can have the same type or different types. For example, for the record ID with the string value Bob, the value of this band can always change to a different string value, like Jaw, or even to a different data type, like integer. All bands can be any native data supported type, like string, int, map, and so on. Working with storages like this one could be tricky because it has no scheme. It means when you create a data model, and here it's a bunny, and when you store it, and when the next step is to get what you have stored, you somehow end up with something unexpected. This happens because you don't know what exactly you will get. Because in case with Spike, the driver doesn't provide you such information. It gives you a record with some object, and you have to get whatever it is there and try to cast it into expected type. We can avoid all possible problems here, but we can reduce the probability of obtaining them by generating passes at the compile time. The only thing we have to connect to Spike from Scala is the driver written in Java. To get bunnies instead of the donkeys, we will have to write a lot of code with it. And let's take a look at this code so you'll understand what I mean. You know, I love to read. All of my free time I spend with classics like Oscar Wilde and Charles Dickens. But I don't like to read War and Peace in Scala when I'm at work. You won't believe it, but all this code does is just writing a couple of different values with different keys into storage and then reading it. I think it's too much for such simple operations. Technically, it does everything, but it could be presented other way, like more Scala way. I want something more simple, more like that. This code does exactly as the previous one, but it looks better and doesn't take a lifetime to read it. This all is type safe, no check-ins, no serializers, no other boilerplate, just a simple application, and you can see what exactly is going on, what you have stored into storage, and what you will get in return. If someone gave me such a library 6 months ago, I would be grateful, and probably wouldn't be here today, so I guess I'm lucky. So let's start with storing the data. This storage doesn't have a scheme, so to store a couple of different values with different keys, we'll have to create a client and prepare a key and bean values. Java client provides several constructors for keys and beans, 7 types of keys and 12 types of beans. So as you can see, more types means more code. But we're in Scala, and we can use any type we want. We have plenty of choices from primitives like int, string, and so on, to more complicated ones like collections of students or tracks or whatever. Because for us, there's actually no limit, and we want to write less code. So imagine we wrote all data into storage, and all values were converted into the internal databases format. But this storage, along with the Java client, has a lot less types than Scala does, of course. For example, int, short, boolean, and byte will be stored as a long value, float as a double, and so on. But we still have to return the exact type that we stored, not the one that it became. The thing is, we will also choose how to store information, which is a plus for us. Take a look at the small bot here. An H-list is a heterogeneous list, which is an arbitrary length tuple. It's basically a collection of values of different types. In case with this storage, where bin can have different values with different types, I think an H-list is a perfect fit. And I decided to store it as a native map value in the storage. I also did the same for the case classes. For example, case class cat will be stored as a native map as well, where keys will be the names of these fields and values the values of these fields. So we stored everything, and now we know how it looks like inside the storage. So all is left to do is just get the information, which is a simple operation, and what can be easier? Oh, well, not this one. Now I have to spend time choosing the right get function. As I don't have enough problems with picking up address, I mean policies, listeners, something unreadable, nobody has to suffer this much, even Java engineers. All I want to do is get one string from the storage. Is that too much to ask? 13 methods. And that's not all of my problems, because these methods will return me an object, and I will have to write passing functions for every possible type, which is a lot of work. Okay, we know that Spike stores data in records, and this is the record that get function will return us. Take a look at this model. Do you remember the donkey that we got from the cylinder? That map of string object is neither a donkey nor a bunny yet. It's some strange animal with ears. But I still want my bunny back, and I will have to work for it. Imagine we have done everything, and still, after all we've done, all fetch and create functions, we still have to write a lot of code with it to get data of the expected type. But when we provide type-safe interface, it means that application of functions should be short and simple. It should be like this. At least this is how I say it. So what exactly schemaless key-value data storage driver has to do? First, I think the API of the client itself has to be more concise and have a user-friendly interface. In my opinion, the less user thinks before actually using, the better. Secondly, I think it has to take care of serialization. Internet is screaming with 100 different libraries and ways to serialize objects. I mean, who hasn't brought their own library to transfer keys class into JSON and vice versa? Not to mention operating with data inside application's code base. Every day we have to face that serialization problem, especially when it comes to Java libraries. And finally, I think it has to work out of the box. Okay, now we can try to move in that direction and see what we can do to build the Trim driver. So, part 3, implementation. Take a look at this slide. We have here a function that knows what to do with keys and bins in type-safe manner. Keep in mind that there is a number of actions that we can do with this storage, like add, delete, and so on. And we have the first parameter for that. I don't want to call key and bin creation functions every time. So I decided to delegate that job to the implicits named key and bin wrappers. So I could just pass particular values of any type I want and let those implicits do all transformations for me. So what exactly happens with those implicits? Let's call the function that will put one string value with a string k into storage. What actually happens here is that values of wrappers of type string will appear in their places. It means that they happen to be in the scope. Otherwise, you will have an exception which says that implicits are missing. And now we can define put and get functions with that smart function to make our API more concise. So to avoid all missing implicit exceptions, we will have to define wrappers. And we will start with the key wrapper for type key. An instance of that helper has to appear everywhere where you communicate with the storage. So we obviously will have to write down more key wrappers of different types. But I don't know what I will use in the future, like strings, int, or a collection of cats. And I don't want to write more code every time. So this is one of those moments when you really want to believe in Santa or someone else who can do all that job for you. And lucky for me, there is some magic that can help. There are macroses. So what is it? Macros in Scala allow to create sections of code at the compile time. They're based in the context class. An instance of that class is always passed to the macro during expansion. Then you can import the universe object and request descriptors of types and methods and so on, exactly as in runtime reflection. So basically, macro is just a function that accepts syntax tree and returns the changed one. I'm a big fan of a code chain. If you have worked with Scala XB or Scala protobuf plugins, those are my favorite. And the idea of macros is kind of exciting for me. But every magic trick has a price. An abstract syntax tree should contain every feature of Scala. And one of the drawbacks of macros is that description of that tree can be not so easy to read. For example, code fragment 1+1 in generation should look like this. And things get worse when we need to present larger pieces of code with this substitution of templates. But lucky for us, in Scala 2.11, this drawback is solved, and we have quasi-quotes. And our 1+1 will look a lot more simple. In general, quasi-quotes is just a set of string interpolators that are located in a universe object. Once you imported those into the current scope, and then you can use a series of characters before string constant, which will determine how the compiler will handle it. So it's basically evaluates to the tree. And now we can define key wrapper with quasi-quotes. Macro materialize. The weak type tag here is the way to get description of the type key with a method from universe object. Macro here is an implicit, which we already know means that an instance of any type of key wrapper will appear in the right place when it's necessary by itself. One more thing. If you need some extra packages to make your code work, you will have to provide those in the scope when you use that instance. That's very important. So what will happen when we try to call materialize for type string? So we will have to create the wrapper of the type string. This is the piece of the compiled code. At compile time, an instance of key wrapper of type string will be created exactly as we wanted, with all imports, methods, and values. So that instance will be ready to use it in the current scope. And what actually happens when we call materialize for different types? Instances of key wrappers of different types, like string in, hlist, and so on, will be generated at the compile time. So it's not exactly a magic, but the code is there, and compiler wrote it for you. And now is the most interesting part, the bins. And this is the bin wrapper trait. It's very similar to key wrapper, but there is also an out type, because we have to get information from the storage. For that, we have an apply function that accepts the record and returns the value of the expected type with some meta information. The difference between types here will be in this very important function, fetch, where we check the type and get in the value of the expected type. And this is the bin wrapper macro. It's also an implicit, also very similar to key wrapper. Since the difference between types here will be in this one function, we can insert quasi-quotes with type checking into quasi-quote. And one more thing, you can use everything with macros, even from other packages. All you need to do is just import those into the macro creation or directly in a file where you use that instance. So in a fetch function, we will compare the results of weak type of function with the function from Scala Reflect API to compare types. We know that string is stored as a string in this storage, but for example, an hlist is stored as a map. And we also know that this storage has a lot less types than Scala does. So that map is definitely not what we ordered. And we will have to get the values of this map and cast them into expected type. To do that, we will write some passing function that will get values of this map and return as the collection of type any. And then we can call the toHlist function from a shapeless package to get the exact hlist that we stored. And we also can do the same for other types, of course. It's just an example. You can use it for case classes or whatever. So what is going on when we call this function to create bin wrapper for particular hlist of int boolean? Instance of this particular type will be created with all imports, values, and methods. Take a look at the fetch function here. It took the right piece of the fetch value with for the exact hlist. So this will be the full instance for the hlist of int boolean. With macros, everything is under your control. If you want to take a look at the result, there is a number of ways to do that, and the easiest one is just to print it, which is exactly what I did to get this example. So we've done everything, and now we can relax because all converters will be generated at the compile time by themselves. So we don't have to do anything more. I spent a lot of time defining the correspondence of the types in the storage and in Scala, but in my opinion, user always has to have a choice. So if you want to store your information in some different way, you can always do that. All you have to do is just specify a custom wrapper. For example, if you have a function that writes values into storage and accepts the bin wrapper and place it, all you have to do is just specify two wrappers. For example, for the keys class check, we can use two options: store it as a map, which is a default case, and store it as a JSON. You will have to pass explicitly those wrappers into the function call, because when you have the two of them in the scope of the same type, compiler will be confused and you will have to help it to pick the right one. So what else is out there? Now we have everything, and we can define a service to communicate with the storage. Along with an int and an hlist, I will store an interesting map where keys are not strings but values of the sample case class. Aerospike provides different tools. One of them is a console tool named EchoL, which allows you to select information, which is very useful during development and testing process. So let's take a look at the result. Int bin and an hlist are fine, but the map bin is empty. It's not actually empty. This tool has an issue. It can show you complicated keys stored. By complicated, I mean any other than a string. But with methods that we just wrote, we can select the information and be sure that this information can be stored properly, and we will successfully get it. To clean up all information that we stored during development and testing process, we can define the cleanup object and call the delete function on every key in the collection. And now set is empty. Sources of this DSL are available on GitHub. Here's the link and dependency to try it. I recently added the cross-buff serialization, and there is a model with examples. There you can find examples of usage, and everything you need is there. So, to sum up, I've told you about Aerospike and how we store information in it, what I think schemaless key-value storage driver has to do, and how to deal with types using Scala macros. I strongly believe that users of any application need to operate with types to reduce errors, and of course to write more beautiful and readable code. If you need to get in touch with me, my contact details are on the screen. Please feel free to email me. Thank you. Any questions? Yeah.
I have a question. For this particular case, could you have used like type classes to provide the mapping from Scala type to Aerospike representation, then leverage the compiler to derive using hlist or something for everything else?
You mean, can you use the actual examples?
Yeah, for example, if you provided like an implicit proof that a string can be represented as a string in Aerospike and a boolean can be represented as a long in Aerospike, then you could have used maybe hlists to say that as long as everything in my hlist can be represented, I can represent an hlist. Or I'm just wondering, like, is it possible to do that, or is it only do we have to use macros?
No, it's possible. You'll just have to write it down. So as I was saying, I will show you. If it's possible to...
Oh, sorry. I'm just wondering out loud. My question was, if as long as the hlist contains elements that have key wrappers, I believe it's possible for the compiler to derive the key wrapper for an hlist itself through type class derivation. So my question was, is there a compelling reason to use macros here, or was it just easier?
No, there is actually a reason, because for the keys classes, I'm using the reflection, the full reflection, and if you use it for like 10 models, it's very valuable. If you can detect the exceptions during compile time, it's better, of course. Thank you.
What about class loading performance problem? I mean that we are generating a lot of garbage. I mean a lot of classes which can be reusable sometimes. So every materializing invocation generates additional classes.
You mean, will there be like some extra classes that you don't use in the scope?
For example, we want to invoke getting method for the same H lists, the same types. Then in both cases, we will generate the same code in different places. So
Yes.
it's okay for runtime performance, but it's not good for class loading performance. Is it possible to solve that somehow?
I honestly haven't tried yet. So, but yes, there will be extra classes in different files if you use the same classes. Yes, that's true. Thank you.
Hi, thank you for the talk. You shown the cases when you're serializing case classes and maps and HLists as maps, and I know that Dati now is coming with a new HList. So
Yeah.
is there a way to extend it with your own types so it's not just like wrong class exception, but like ability to extend and add your own types there, looking like maps or like numbers or whatever?
Can you please be more specific?
For instance, if Dati adds new type of the H list and we still want to serialize it as map, is there a way to add it to your plugin, to your driver?
All I will have to do is just change the exact H list that I use, and that will not affect users. Thanks. That's it? Yes? Of course.
If I want to use your approach, but I want to also verify every field before I save it to database, do I need to write extra macros, or I can solve it easily with HList approach or some other approaches? So do I need macroses if I want to verify each field before I write it into database? If it's not verified successfully, I want to get an exception. So should I add more macroses in this case?
No. No, you don't need it. Actually, if you have like a couple of types that you want to use, there's no need to use this approach actually. So
if I just want to verify every field and return result as a list, I don't need this approach. I just have similar problem, but we also need to add verifiers for each field. And I'm wondering, do I need to add extra macroses, or I can just take this library and add some verifiers?
With the different database, right?
Mm-hmm.
This one is specific for the Aerospike because it transfers the values of the Scala into the Aerospike's Java client values types, and then it gets to the storage, so it's not fitting for other databases, but I can help you if you will show me.
Thank you. So for verifiers, I don't need extra macroses.
Maybe.
Okay, maybe
I'll try to help you.
Outside of scope. Thank you.
Thanks.
I was wondering, maybe this kind of goes along with the verification thing he was talking about, but like, so it sounded like for ints and shorts and bytes or whatever that it gets like casted, or maybe not casted, but it gets put into a long, and the long is like how it's like in the database, right? So when you're bringing something back out, how do you, because it's a long in the database, how do you ensure, like maybe you stored something as an int, but you're trying to pull it out as a byte, something that wouldn't really fit in. How do you prevent like that error?
Yeah, there's no errors because I did it for quite some time. So I figured which type is stored in which way. And for example, for an H list, I will have to get the names of the types alone zipped with a collection of actual values, and then I will cast pairs of these types. And I have a collection of types that are, complicated. In this case, it's 4 rows, for example, and I will have to cast it every type. I can use actually for collections like something from Shapeless, but it doesn't fit here very well.
Okay. So in that case, then the type, like the original type, also gets stored in the database along with the value being stored in the long? Is that what you're saying?
Can you be more specific, please?
Well, like say I want to store an int into the database, and okay, it gets stored. That's fine. Later on, like I accidentally think that I want to pull a byte from the database. It's like it's all stored in a long. I want to pull a byte from the database, and because I messed up my types, because it's supposed to be an int, it could be longer than what a byte can hold. How do you prevent, or is that like built into the system that if you're putting out an int, you're always getting back an int, or?
No. In this case, you don't own the database, so someone can always change your value, of course. And there's actually no insurance for that. But if you use in the right way the function call, you will specify the type that you want to get.
Right.
And if you're trying to get like wrong value, you won't get it. You'll have
It'll
an
just
exception.
be like a regular exception in that case or something?
Yes.
Okay.
Yes. And more than that, you will have exception even if you fail it to compile the wrapper. So maybe it's not even possible what you're trying to do, which is better, of course, than catching it in runtime. Thank you so much.
Anyone else? Okay, thank you.
Okay, thank you so much.